a little bit of throat clearing first. It's very nice to do something that the law school here, Melbourne Law School, is involved with, considering I spent so much time here. And I really appreciate doing something that Liquid Architecture is involved with, an organisation that I've been involved with myself for a number of years. And I really appreciate the curatorial efforts of Joel and James. It's been really rich and warm and pleasurable to participate in the program in a way that has directly contributed to the material that I'm going to deliver, including this workshop that we did on Wednesday that really prompted a lot of ideas and that I've been trying to sort of synthesize since into this presentation. It's also really an honour to share a podium with Mark, whose work I've admired and followed for a really long time, and I will refute James. I definitely feel like an opening act, but I'm very happy for that to be the case. So today I want to talk about the way that computers interpret people. And it's something that I've thought about for quite some time. It was sort of the underlying topic of my doctoral dissertation. And I suppose the title Computational Eugenics is a little bit alarmist, and you'll have to forgive me for that. I'm not going to be talking about forced sterilization or anything like that, but rather you could think about it in terms of the combination of technologies and politics of classification happening all at once. I want to talk about how technologies participate in classification, how they perform those classifications, and to a degree how particular politics get embedded in those mechanisms, in those technical operations. And in fact, we will see that that a lot of these techniques actually have origins in eugenicist practices, and we'll see certain eugenicist ideologies as an example of the kind of politics and ideologies that these techniques try and launder and dissimulate and hide. But there's all sorts of political programs that get embedded in technical systems. So exposing all of those programs isn't necessarily the goal. And while I'll talk a bit about the eugenicist history of some of these computer vision practices and computer listening practices and some of this history, I think it's important to reflect not just on how those politics get embedded in technology, but what they actually reveal about the technology itself, what it reveals about the apparatuses that are doing this, because to me this is becoming a more urgent concern than necessarily exposing any one particular problematic application of this family of techniques and technologies. So the plan is to discuss a couple of these emerging techniques for classifying people, and then to talk about the technical and epistemological platforms on which they operate. And in order to do this, I need to talk about the relationship between classification and measurement and how they exist in these technical systems. This is a quote from Ian Hacking, a philosopher of science, whose work I found very, very interesting. He writes a lot about the history of statistics and the history of probability, and I think there's something very meaningful in this idea that every time we come up with a new way of measuring something, we also come up with a new way of classifying something. And this is not necessarily an entirely nominalist position. I think it's a really important way to think about the systems that we use to understand the world around us. So my particular interest in the techniques that I'm going to talk about now come from both my previous doctoral research, which looked a lot at photography and other different kinds of representations and how they represent people in state surveillance systems. And how those practices are being performed by a variety of technologies now, including these computer vision technologies. So these are two now very, very notorious articles. The authors of these papers claim that they've been able to build machine learning classifiers that can analyze images of people and determine to a high degree of accuracy, on one hand, the sexual orientation of a person, and on the other hand, the criminal propensity of a person. To me, the claims in these papers represent something a little bit novel or a little bit different from the claims of other big data. Let's call them profiling systems. There's a lot of material about big data epistemology and the movement from causation to correlation as a way of knowing the world, as a way of understanding the world. But to me, these applications of computer vision are doing something a little bit different to what we've thought about in terms of online profiling over the past sort of 2 decades. The first thing is the nature of the input data. When we think about online profiling, we think typically in terms of transaction-generated information, right? Profiling through proxies, profiling through our interactions with informational environments, with cyberspace. We think of data being aggregated from multiple databases, data that's already hypermediated, already very attenuated from its in its relationship to its referent, With these computer vision projects, the data input for classification comes from one place. It comes from an image of the real world. So we're no longer really talking about online profiling anymore. Instead, we're talking about profiling in cyber-physical systems. Right? These are the technologies that participate in translating the physical world into the symbolic register of computation, as well as re-articulating automated decisions that happen in computational systems back onto the physical world. So it's not just about collecting data. This is automated systems doing things in the world, controlling access to public and private spaces and infrastructures on the basis of who you are and increasingly what kind of person you are. So, for instance, like an automated number plate recognition system that levies a fine against you on the freeway. We're now seeing systems or facial recognition systems that won't give you access to a public toilet because you've already used it too much, right? Or sports events where people can't enter stadiums because they've got prior violent criminal offences. And it's not hard to then imagine things like the shopping centre car park that you can't access because you're not a good enough shopper. Or things that are potentially coming like being denied access to transport and visas because of your history of political expression. So this interrelating of digital and physical is happening very quickly. I mean, people talk a lot about Internet of Things, and maybe for a lot of us that doesn't really mean very much. But as some of us learned this week, these web-enabled home assistants that work with speech interfaces, another form of this cyber-physical interaction, are the highest or fastest growing consumer electronics product ever in history. Computer vision is probably as ubiquitous. There is a product in most Android phones now called Google Lens. Right? It will tell you a lot about breeds of dogs when you point your camera at them, what kind of flower you're looking at, what building you're looking at, what people think of a particular restaurant. But we have a question about what it can tell you when you point it at a person. So I suppose I'm suggesting that there are very high stakes when we think about automated systems looking at people or listening to people, because those automated decisions increasingly have consequences in the real world. And with respect to computer vision, for instance, it's not just facial recognition, which is already a very powerful form of identification because it links an institutional identity to a physical location, but also things like behavior detection, sentiment and emotion analysis, and personality typing. These are all examples of different computer research projects that do personality typing a certain way. This middle one is actually a pastiche of that that's done by some really interesting researchers here at Melbourne University in the engineering school. But we can do this with all sorts of different techniques. This one down over here is measuring trustworthiness in people's voices from the way they say hello on a phone. The second thing that really struck me when I was reading this research was the nature of the conclusion that exists in both of those articles, but is particularly explicit in this Wang and Kaczynski paper is that there's more information available in a human face than a human can perceive or interpret. Right? And as such, it becomes only available to us as knowledge through a set of computational, empirical, and analytical techniques. Right? And that's where we get to these positions that computer-based decisions about humans are more accurate than human-based decisions about humans. To me, this again really challenges the way we have historically or continue to think about technology's relationship to reality. Because when we typically talk about technologies and how they intermediate, we typically talk about loss, right? It's the inevitable reduction of the smooth analog world into quantified bits, right? And the highest praise for digital audio is that it's lossless. Yeah. And the legal critiques operate on that basis as well. You know, it's always that the digital double or the digital doppelganger is a poor reflection of the person, right? It's a distortion, it's a reduction. It's based on proxies too attenuated from their natural starting point to have any real meaning. Now, instead, the claim made by profiling technologies is that only through computation can we access the truth of reality in faces, in bodies, in whatever else. So the technical narrative moves from loss to augmentation. You know, imagine this. On this side is like a common kind of metaphor for facial recognition technologies. You take a certain number of data points, measurements from a face, and from that you can individuate a person out of the billions of other people in the world. Well, this is a total caricature. It's sort of entirely wrong. And ever since convolutional neural networks were used for computer vision in around, were demonstrated their success in computer vision in around 2012, the way in which this is done has changed a lot. Now we use these technologies that are very, very difficult to represent visually. The neural network that's used in the Wang and Kaczynski paper concerning human sexuality, called VGG Face, goes through this process and ends up with around 4,000 measurement points per face. But to do that, it starts with a whole lot more, because we begin with every single pixel in an image representing a measurement point, and the red, green, and blue values of each of those pixels representing a measurement point. So this is not really what's happening. It's more like this, right? And so what we're actually talking about isn't really even images anymore. It's statistical maps, right? Statistical maps that actually humans can't navigate. So there are these new narratives at work in technologies like computer vision, it seems to me, and the methods of data science that suggest we're not really dealing with proxies anymore. We're not dealing with approximation. Instead, we're dealing with revelation. Now, we might dismiss this as absurd, but I think that would be closing our eyes to this sort of pressing reality that data science has become a very significant organizing principle in the world. It's actually become far more than just a method. It's become a sort of form of applied philosophy. And this is the point made by a very interesting writer named Dan McQuillan. So, it's important that when we think about new algorithmic knowledge logics, we think about where they've come from. And indeed, using the statistical analysis of images in order to classify people has a very, very rich history. And what this historical look does for us is demonstrate, on the one hand, that these computational technologies are clearly not neutral. They're clearly not without politics and ideology. We can make that point relatively quickly because I don't think it's particularly controversial anymore. I think it's quite a well-accepted position. But on the other hand, I think what we see out of this historical look is an interesting evolution in the theorizations and the techniques that have been deployed in terms of understanding people in these kinds of ways, in these very empirical ways. So we go back to Sir Francis Galton, who was more or less the founder of eugenics. It's probably like the most cited scholar, practitioner, progressive reformer, utopian, racist at the moment. As I said, I think quite a lot of people are thinking about this. And he actually introduced this, this process of statistical photographic analysis in order to test his hypothesis of biological degeneration, right? This eugenicist idea. And he used a composite portrait technique on what was the very first comprehensive photographic data set, criminal faces. There's a whole another story around why criminal faces were really the first photographic data set, but I don't think we have time to go into that now, let alone, let's say, every time you went into prison or you went to a trial, you had your photograph taken at the gate, at the court, outside the courtroom. And so there emerged this photographic data set of criminals, and Francis Galton, through ideas around the mechanical objectivity that the camera afforded, thought that he would be able to create a composite portrait by exposing multiple criminal portraits on the same plate in order to reveal the criminal mean, right, the average. Galton's experiments failed. He instead claimed that rather than actually exposing the mean of criminality, what he'd done was demonstrate the common humanity in everyone. Right? When the composites were added together, he couldn't visually distinguish the populations from the images. He couldn't visually separate it. He couldn't say criminals look like this and non-criminals look like this. Despite Galton's failures, these investigations into physical morphologies and criminality, as well as other traits, absolutely never stopped. And they continued at lots of different institutions in lots of different disciplines. What they have done is move away from the group of ideas that were sort of colloquially termed social Darwinism. And instead, they now deploy a literature from psychology that indicates that humans are really, really good at making judgments about people from sort of first impressions. In other words, the researchers are saying, look, faces clearly convey information. The psychologists have done lots of research that makes that perfectly clear to us. We're just investigating this further. So what we find is this gradual evolution in the theory used to justify this work. Some use this sort of social inference hypothesis, this idea that we're just sort of investigating how and why humans stereotype. And some claim prenatal hormone theories, this idea that exposure to androgens in the womb creates characteristics about personality and appearance. Some use these sort of evolutionary adaptive studies, which suggests that there's an evolutionary benefit to being able to make quick judgments about people. But all of these theories are pretty bogus in their own way, and there's never really been a stable, coherent account. So it's sort of data science to the rescue, right? Because data science allows us to continue exploring statistical correlations, but unpinned from theoretical accountability. We're no longer exploring biological degeneration, we're simply measuring and doing some maths. And this is why in 2006 we saw machine learning applied to this problem for the first time. And since then, these very legitimate sub-disciplines of computer science called apparent personality recognition, apparent personality analysis, which look for non-visually evident and non-sonically evident patterns, right? Personality traits. And there are ongoing conferences, there's ongoing competitions sponsored by companies like Google and Amazon, as well as Microsoft, Facebook. Disney's an interesting one, but I don't know, Walt Disney has a bit of a cloudy past as well. I'm not making any suggestions that that's what's animating this. Now, we could dismiss these physiognomic exercises as scientifically baseless in much the same way that early phrenology and physiognomy were dismissed. It's not difficult to argue, I'll go to that in a second. It's not difficult to argue that what's actually at work here are structural class signifiers. It's not difficult to argue that sexual classification systems are ignoring an entire canon of queer theory, and that the idea that sexuality is performed. But I don't think that really matters to the people, the practitioners of these technologies. I don't necessarily think that those particular examples about sexuality or criminal propensity are likely to become operative in the world. I think what we're going to see is less egregious exercises, potentially used in hiring decisions, used in online dating apps, potentially law enforcement body cameras that use early warning systems and use various sorts of analytics to demonstrate that someone might be about to commit some sort of violence or about to run away. We're unlikely to see, fully automated systems based exclusively on static facial information, right? Just how you look rather than what you do. But I sort of take this point from Nicole Rafter that even though phrenology and physiognomy, for example, were scientifically erroneous, they were far from an error and they were far from insignificant. Because these early sciences were a critical part of the movement of theology and the idea of sinning as the way we understand what a criminal is, to a sort of analytical empiricism whereby measuring people was the way we understood what criminality was. And measuring was the way that we should understand the world. So this had a very, very dramatic and lasting impact on the way we produce knowledge about people. And I think we need to understand that these computational exercises, in the same way, potentially represent a shift in a knowledge-producing paradigm. Right? To see what I mean, we can go back to this Wu and Zhang paper. And here, the authors actually find it surprising when they try and create average composite images of the criminal and non-criminal populations that their machine learning classifier has separated. Right? They are doing exactly what Galton tried to do, and they're failing in the same way. They say, we can't visually distinguish these populations. And we're surprised by that. The way the experiment succeeds is by separating the populations not on the visual level, but at a statistical level, and in particular, a high-dimensional statistical space. So it's not the visual character of this information that's important anymore. It's the quantitative measurement only. It's the reduction of images into numbers and the statistical analysis of these numbers. And so what I'm suggesting is that potentially as politically significant as anything else in this paper, what's at stake is the idea that knowledge is only numbers. Right? Because the stakeholders in that who are going to come out on top are the people who have the biggest computers. Now, some computer scientists sensibly tell us that deep learning can't extract information that isn't there, and we should be suspicious of claims that it can reliably extract hidden meaning from images that would otherwise elude a human judge. Such an admission, however, strikes me as very, very peculiar when deriving meaning from measurements that are too granular for non-computational analysis is the very premise of machine learning. So we seem to be moving away from a paradigm of comprehension and into one of computation, away from observation into measurement, away from the clinical into the empirical, away from the qualitative into the quantitative. And with the truth, the idea of truth, the sort of deeper hidden reality only available in these high-dimensional spaces that only neural networks can access and process. So it's important, I think, then to really think about what is being measured here. How is it being measured? Because this is going to help us challenge such an understanding of these measurements, or an understanding of these measurements as access points to the hidden structures of reality. What Dan McQuillan means when he describes data science as a sort of machinic neo-Platonism. So as you may have realized by now, computer vision systems don't see, right? They measure. Computer listening systems don't hear, they measure. Right? They measure visual or audio data to determine a world state, the nature of the world that they are measuring. Now, this is really, really difficult because, for instance, when we think about images, we come from the starting point that any two-dimensional image is an abstraction of a three-dimensional space into two dimensions. There are therefore multiple configurations of that three-dimensional space, or that three-dimensional world, that could result in any two-dimensional output. Right? So the chance that any possible world state is present or true has to be described using probability. But this is also not particularly controversial. All our knowledge is kind of probabilistic in some manner. Society is very inherently statistical. You know, this is sort of the proposition of quantum mechanics. And there is absolutely an imperative project in understanding all this sort of stochastic grammars and idioms that are at work here, but I think we can't quite go that deep. Now we're just going to try and focus on how these systems measure and what those measurements mean for classification, because that is alone complex enough. Because what these systems do is measure really, really closely, right? They measure much more closely than was previously possible. And in the same way that photography was said to expose everything that had bypassed the optical unconscious, these computational systems do notice, they do measure, and they do analyze a lot that was previously unavailable to human perception. But they don't measure everything. Right? Machine learning is very computationally demanding. And it can't operate on the sort of totality of all data that can be derived from an image. As we talked about, when you start using every pixel as a point of measurement and every color value in a pixel as a point of measurement, the level of computation you need to do to cluster those measurements to derive meaning it becomes pretty staggering. So we have this idea of computational economy that requires transformations of data into symbolic representations that computational systems can process. Right? Through a machine learning method, a system has to marshal particular selections of data, what are called features, into particular representations. Right? This is called representation learning. It's where a system is fed with raw data to automatically discover the representations that are needed for detection or classification. So this is a measurement step, or one of the measurement steps. The first measurement step is who gets the microphone or the camera pointed at them. Right? But then, once that data is collected, we have another measurement step, a measurement necessary to transform that data into an internal representation. Now, scholars like this computer scientist, Herbert Dreyfus, have argued that the reliance on representation is AI's ultimate failure, right? It's what takes AI out of the world of the real. Nevertheless, it remains the primary mechanism by which computational systems measure the world. And what it means is that we have new types of representations associated with images, right? Not natural representations, but mathematical representations, not the icon or the index, but linear representations where images are unwound into vector matrices, spatial frequency representations which measure the speed at which a particular quality changes across an image surface, or relational representations where images are represented with graphs. Not to mention all these probabilistic representations where we use these mathematical tools to estimate the best version of a particular image given its corruption or noisiness. So we have to ask this question, right? Is this hidden mathematical structures of reality or just some sort of para-reality, computational reality? Thank you, Goldie. I think what's absent is this sort of imagistic critique of quantitative empiricism, that all measurements are partial and that all quanta are polycentric. The difficulty is now we don't really even know what's being measured, right? And getting access to the representations is very, very difficult. We've kind of given over the task of choosing the representation to a machine. So it's difficult to even call this biometrics anymore, because what we're measuring might be absolutely nothing biological, right? We might just be measuring pixel gradients. It's really kind of a mystery, or it's just incredibly, incredibly complex. How are we going for time? Maybe I'll skip this section. I'll just leave this video up because it looks cool. So I was going to talk about this idea of dimensionality in more detail, but I think maybe it's something we can discuss in the Q&A if anyone's interested, because I want to move on and let Mark talk about the issues that he wants to talk about. But maybe I'll just quickly talk about what then might be the proper response for law, right? For social sciences, how do we translate these limitations in a knowledge-producing system into sensible limitations on their application? How do we address the idea that data science has become more than a method? It's become a pervasive applied philosophy in the world. How do we challenge the epistemological reverence for a hidden layer of reality which is ontologically superior, expressed mathematically, and apprehended by going against direct experience? How do we ensure that as the digital within cyber-physical systems comes to constitute the world, it doesn't at the same time constitute our understanding of the world? Right? How do we deal with the reality that as computational systems increasingly cast their decisions and classifications into the world, we become increasingly located within a world coded by computational imagination? You know, if humans cease to decode these images and instead project them back out into the world, we get what Willem Flusser describes as the world itself becoming like these classifications. Just a context of scenes, right? Just a context of states of things. How do we clarify that computational systems are merely apparatuses combining and computing symbols that encode the world in a particular way according to a particular program? There is one register of criticism directed at ensuring that there's no sort of bias or prejudice at work in automated decision making. But I think we have to be very careful that this isn't data science enrolling law in the humanities within its own project of completion or perfection. I think this is the risk if we think about these things only at the level of application or consequence. There is another legal register of accountability, often now framed in terms of explanation or interpretability. On one hand, this might be incredibly unhelpful. What good is it to be told that this part of your face makes you look like a criminal? But on the other hand, it can be very, very helpful because it exposes the representations that are at work in any decision making. But beyond that, I think it's important to make clear, and I think law has a really important role in this, that however optimized these systems are, data science is just one way of knowing. And the imperative is to challenge the dominance of computational empiricism, and it's locating the world of possibility, the world of infinite possibility, only in the data. And I think we need to avoid what Jacques-Alain Miller calls this insanity that is proper to logic, whereby by measuring everything, logic conceives a world in which all things are relative, makes itself absolute, and denying the whole of nature establishes its own artifices. And the last thing, these artifices are becoming more and more visible, visible across multiple registers. Through training classifications, we also train computational synthesis, right? The computational imagination that gets cast back into the world. So we have to think about what it means to navigate a world in which computation is capable of synthesizing and hybridizing low-level features like eyes, as well as high-level features that are, concepts like what a celebrity looks like, or telling us what a particular experience sounds like, right? Or even telling us just from a single image what a three-dimensional space looks like. Because these are all done by computational imagination. And we have to be careful that when this happens, yeah, it's really weird. We have to be careful to not interpret these things, that they're as good as true. Thanks very much.